In this video tutorial, I will show you how to create a simple application in Platform. During this process, you will get familiar with the basic development tools and learn to launch our application and monitor its performance in the application designer. This application is called Factorial. Let's see how it will look for end users. When the application is launched, we can see a form where we need to enter a number and click on the button. After that, we move to another form where we can see the result, which is the calculated factorial of this number, and then complete the process. In the application designer, the application looks like this. On the left side, we see the application structure. Here, we have one module that contains several packages. In turn, each package contains certain objects. In this application, we have one process that looks quite linear. On the first form, we enter a number, then comes the script that calculates this number's factorial, then the second form shows the result of this calculation. Forms in the application designer look like this. This tutorial can be used as a general guide, and you can follow along to configure a similar application in your environment. We will assume that you already have access to a platform test instance, have successfully logged in, and created an environment. So, we will start by creating an application in this environment. First, let's talk about the naming style used when developing an application in Platform. While developing applications, it's recommended to use the snake case notation when naming objects. This means that all words should be written in lowercase, and if a name contains several words, they should be separated with underscores. To create an application, open your environment and click the Create button. Then fill in all the required fields. In the application name, using the snake case notation, type Factorial. The alias will be displayed in the interface of the final application, so here you can set a name that is more meaningful to the user. It's also recommended to add a label that identifies you and shows that this is your application. For example, you can add your last name or your username. This is a useful practice due to the fact that several users can work in the same platform instance and do the same tasks. So that you don't confuse your application with other applications, identify it with meaningful alias. And next, check the Launch Application in Debugging Mode checkbox. This means that the UDM console will be available to us. And check the Allow Manual Issuing of Physical Names checkbox. As a result, an additional field prefix will appear. A prefix consists of 3 Latin letters, and again, it's recommended to choose this prefix in accordance with your specific application. For example, if I set the prefix FAA, it means Factorial Application Admin. You can also use your initials in the prefix. In this application, the Allow Manual Issuing of Physical Names checkbox will not play a very important role, but in training applications, it's still recommended to use this option. When we set physical names ourselves, it's much more convenient to maintain the application later, write SQL queries, or transfer the application to other instances. Then there will be no confusion. If this checkbox is not checked, the system automatically assigns physical names to database tables. After filling in these fields, click Save. The new application will appear in the list. To open the application editor, double-click on the application name. On the left side of the screen, you can see the structure of our entire application. On the right, you can see the tabs of specific objects editors. At the moment, there is one open tab, which is for setting the parameters of our application. The application structure already contains one module called main. It's empty. Clicking the plus sign opens the menu of objects that can be added to the application. Let's create a new module and delete the old one. If we assume that our application will be further developed and refined, then it's better to come up with more functional names for modules. A module is a functional unit that is required in an application. Now I will delete the old module that is called main. After creating a new module, you can fill it with packages that will visually group objects by type. You can create packages one by one or as a batch. Now let's create several packages at once for different types of objects. The data package will contain types, which are tables stored in the database. The dictionaries package will be used for directories and classifiers. The API package for functions. The processes package for processes. And the forms package for forms. In our case, we need only two packages, for a process and two forms. But we will create several packages at once because it's a good practice in case the application expands in the future and to prepare a good base in advance. When adding packages, they appear in our module. Now let's create a process. To do this, select the package where the process will be located, click the plus button, and select process. The name of the process should be functional and reflect what exactly this process is created for. In our case, since we have only one process and it's an interface process, we will call it main. It will be the main process. Now we will start building a process diagram. Any process must contain the start block. After that, we will have a form for entering a number, a script for calculating the factorial, and then a form for showing the result. After the result is displayed, we will move to the end block that completes the process. To connect the blocks, drag the arrows from block to block. It's recommended to build clear diagrams to make them easily readable. When we save our progress diagram, the diagram blocks are automatically given standard names. It's recommended to change these names to more meaningful ones. The first form is for entering a value. We will name it input form. The script is for calculating the factorial, and we will name it calculate factorial. And the second form is for displaying the result. We will name it output form. Note that after saving the process, some errors appear. Basically, this can happen for two reasons. The first reason, as our case, the blocks are not fully configured yet. We will finish configuring them later, and then these errors will disappear. The second reason is that you have some mistakes in scripts or somewhere else in the process logic. To work with application data, we use attributes. Both processes and forms have attributes, so we can bind process attributes to form attributes and pass data from a process to a form and vice versa, from a form to a process. In our case, we will enter a number on the first form, pass it to the process, calculate its factorial in the process, and then pass the final value to the second form. Process attributes are created on the Attributes tab, the third tab on the right panel. Here, as you can see, there is already one attribute called Result. This is a default attribute. You don't need to rename it, change its data type, or delete it. This attribute is needed to configure arrow transitions in the process. If you need additional attributes, even if they are string attributes, and they are used to store some result, you can simply add a new attribute. In our case, we need two attributes. They will be integers. The first attribute is for the input number, and the second attribute is for calculating its factorial. When adding an attribute, you need to specify its name and type. We will name the first attribute input value and select its type integer. The second attribute will be called output value and will also be an integer. Note that these attributes have a physical name column, which doesn't contain any values yet. A physical name is given to an attribute when the corresponding table is created in the database. We will get back to this later. Now let's move on to configure the forms. After that, we will finish configuring our process. To create a form, select the package that contains forms, click the plus sign button, and select Form. The first form according to our process block will be called Input Form. Form names don't have to be exactly the same as process blocks names, but it's better if they match. When creating a form, the Enable Strict Context checkbox is checked by default. It's recommended to keep it checked and create all forms with a strict context. If this property is enabled, then this form will be encapsulated and will depend only on its own attributes. This is important in future development when we need to reuse the form in different parts of the application. After creating a form, the Form Designer opens in a new tab. On the left side, you can see the palette that contains ready-made widgets that can be used in the interface. For each data type, we can find a suitable widget. For string values, we would often use text fields. They can be standard text fields with a template, for example, to enter phone numbers with a dash sign to separate between the country code and the phone number, or text fields with validation, which allow us to set regular expressions and limit the number of characters in the field. For numbers, integers, or floats, we can use the number field or the sum field widget. If you need to be able to choose a value from a set of predefined options, we can use the drop-down list widget. We can also choose values using checkboxes, radio buttons, or other selection controls. There is also a group of widgets for the date data type. I recommend you to get more familiar with this list of widgets. In our case, we will be entering a number, so we will need a number field. And also, in order to move to the next block of the process, we will need a button. Before we continue configuring these widgets, let's take a look at the form attributes we talked about earlier. Form attributes are set on the Attributes tab, and here you can also create an attribute for any type. In this form, we need only one attribute. It will be called Input, and it will be an integer. We are naming this attribute without the value prefix so that you can see the difference between the form attributes and the process attributes. Since the Enable Strict Context checkbox was checked for this form, the form is now independent and sees only its own attributes, and these attributes cannot be accessed from the outside. So, to be able to pass the input value to the process, we need to check the input checkbox for this attribute and change the type to integer, then click Save. Note that these attributes don't have the physical name column, which means that the form attributes are not stored in the database. Now let's get back to configuring widgets. It's recommended to change widgets' names to more meaningful ones. Here we see that system names consist of the widgets' names and serial numbers. While you are learning, you can leave the system names unchanged and just change the number to what each field is related to. Next, we need to set the label that the end user will see on the form. Here, we will write enter a number. Now we need to bind this widget to the form attribute we have created, so that the entered value can be stored in it. To do this, in the value property, press the F button, which stands for function. This will open the value editor. Here, we need to say a few words about editors. In fact, each application has several types of editors. This is due to the fact that several languages are used for development. The first language is UDML, Native Platform Language. The second one is JavaScript. There are editors that allow you to work with both languages at once. These are UDMS editors. In our case, we will use only the UDML syntax. All objects created within an application, such as processes, forms, types, functions, process attributes, form attributes, are UDM objects. Let's get back to the editor that we have opened. To simplify the configuration procedure, there is a reference tree on the right side of the editor. It contains objects, attributes, and built-in UDML functions. In our case, we need to refer to the form attribute. The number that we enter on the form will be saved here. Next, let's configure the button. Here, all default property values will remain unchanged, except for the label and system name. Save all changes and proceed to create the second form. In the Object menu, select the form object and set its name according to the name of the corresponding process block. We will name it Output Form. This form must have a strict context too. This form will display the calculation result. Let's add the same number field as in the first form, but make it uneditable, since we don't need to edit anything here. To do that, set the read-only property to true. Change the system name, and let's change the label to Here, we need to specify the value, but to do that, we need to create a form attribute first. Let's create a form attribute. Name it Output, attribute type integer, and check the input attribute checkbox, and save. Since we will need to calculate the factorial in the process and pass it to the form, we need the attribute to be read by the process and be able to store the result. Go back to the value of the number field and specify the form attribute we've just created. Since we also have an arrow leading from the form block to the end block, we need a button in order to complete the process. Change the system name, button exit, and change the label, exit. Now the second form is ready. Click Save to save changes. Now we're ready to configure the connection between the process and forms. Let's go back to the process diagram. In order to link a form block in a process to a pre-configured form, double-click on this form block. This will open the block editor. Here we can select the needed form from the drop-down list. Set the performer role to all and save the form block. We can also change the properties of the form block on the right panel. Here we need to link the process attributes to the corresponding form attributes to connect their individual contexts together. For that, we will use the property called Form Instance Initialization Values. Clicking on the arrow opens the Complex Types editor, where we can set a one-to-one connection between the attributes. Click Add, an empty line will appear. In the left column, we will select the form attribute Input. In the right column, we will specify either a UDML expression or a process attribute. Please note that the types of the specified process attribute and form attribute must match. For example, we can pass a string to a string, an integer to an integer, a complex data type to a complex data type. Another important note is that here we should try to establish a one-to-one connection between the attributes. Technically, here we can specify a UDML expression or some function, but since all calculations are better to be displayed clearly somewhere around, it's better to call UDML expressions and functions in a script, and to configure one-to-one attribute connections in the complex type editor. Click Save. Now the first form block is configured. Now let's configure the second form block. Double-click, bind it to the form Output Form. Select All in Performer role. In this form block, we also need to link two attributes, the form attribute and the process attribute. Next, let's move to the script block. Open the script by double-clicking. Note that here we can see a similar editor, only this time it is a UDMS editor. This means that in process scripts we can use both the UDML language to access objects and UDML functions and JavaScript. In this video, we will not go deep into the syntax and script writing. We will just use a built-in UDML function to operate our UDM objects. In UDMS editors, it is necessary to use the UDM colon and two brackets operator when referring to UDM objects, and enter the needed expressions in these brackets. Platform has a built-in function called Factorial, and this is what we will use here. When the function is selected, a short reference is displayed under it, giving information on what kind of a function it is, what it takes as input, and what it returns. In our case, it will take the input value process attribute as input and return its calculated factorial. We want to put this calculated factorial in another process attribute, the output value. To assign this value, we use an assignment operator in UDML type column equals, and at the end of each line, we must put a semicolon. This way, we will calculate the factorial of the number that came from the first form and put the calculation result in the process attribute. After that, this process attribute will pass its value to the form attribute connected to it because we have already configured this connection. As for the arrows, since we have a linear process, we don't need to change the arrows. The default arrow type is standard, which means that the process will always follow this arrow in any case. A bit later, we will discuss this case when we may have several arrows and need to set conditions for them to let the system know what block to move to. Now we can save the process diagram. Now notice that all errors are now gone and the diagram is saved successfully. Now our application is almost ready to be launched. We only need to add two small but very important details. First, we need to configure the process so that it starts automatically when we open the Form Runner. Form Runner is an interface for launching ready-made applications. To do this, open the Execution Policy tab on the right panel and check the Run when creating user session checkbox. Processes that have this option enabled are called interface processes. This means that they are launched automatically when the Form Runner starts. Secondly, we need to make sure that our application is in the launched state. It means that it's active. In our case, since this application is new and has never been launched before, its status is stopped. In order to change the state of our application, we need to launch it. To do this, click Launch at the top of the page. If our application has already been launched before, you can click Relaunch instead. In our case, this doesn't make any difference. You can click either Launch or Relaunch. Let's launch the application and then we will talk more about the relaunching operation. After we confirm the launch, we can see that the application state has changed. For practice, I will now relaunch our application so that you can see how it goes in a running application. Again, confirm the operation and wait until it's completed. Since our application is small and doesn't contain any tables, it is relaunched very fast. After the application is relaunched, the system will ask you to refresh the browser page. Confirm this operation. Refreshing the page is necessary in order to see the changes that have occurred in the application. On the Attributes tab of the process, we can see changes in the process attributes. Notice that in the physical name column, all attributes have been assigned physical names. This means that the database now contains a physical table for process attributes. Now we are definitely ready to look at our application through the eyes of end users. To do this, you can either click the Run button on the Start page, log in, and then find our application in the list of running applications. Find it and click Launch. Now we are in our application. There is a second way. You can open the application properties and click on the link in the Link to Application Instance property. When testing your application, it's recommended to work in two browser tabs at the same time: Form Runner and Application Designer, in order to understand whether the system is working correctly. We can monitor how the process is running on the Process Monitoring tab. Here, we can see all running instances of our process. Since this process starts automatically, a line appears in the list of instances, which indicates that our instance of this process is running. Here we can see the process version, performer, and start time. In the same way, the General Process Monitoring tab shows us all running process instances within the entire application. So you can monitor process instances either in a specific process or in the General tab. To view information about a process instance, double-click on this instance. This will open the monitoring window. Here we can see that we are staying on the first block. Below the block is the login of the user we are using. This means that the form was assigned to us at a specific date time. Next, we enter a number on the form and click the button to calculate the factorial. Now we are transferred to the second form. At this point, we can update the status in the monitoring window and see that we have automatically passed through the script block and landed on the second form. When blocks have a green frame, it means that everything is going well and there are no errors. If you see a red frame around a block, then most likely there is an error in the process execution. In this case, you can find information about errors on the Process Execution Errors tab, fourth tab in the monitoring window. On the Data tab, you can see the values that are currently stored in the attributes of the process. Here, we can see the value 5 in the input value attribute and 120 in the output value attribute. After we click the Exit button, we see a white screen. And in the Application Designer, we see that no blocks is outlined in green anymore. After we update the list of process instances, the line related to the current instance disappears. But it appears on the History tab that contains the process history. On this tab, we can open our instance in the same way and go through all the steps that were performed while the instance was running. On the Actions tab, we can see the list of the blocks through which we have passed. And on the Data tab, we can see what values were in the process attributes when the instance finished running. If we want to start this process again, then we just need to update the page in the Form Runner. This will start another instance of the process. In this case, we can update the list of instances in the Application Designer once again and see the new instance. The Data tab is still empty. Let's follow the flow of data between the process and the form. Click Calculate on the form, and now the Data tab contains two values. Let's review what we have covered in this tutorial. We have created a simple application in Platform and got familiar with the main application objects, modules, packages, processes, and forms. We have learned how to launch applications in the Form Runner and monitor their performance in the Application Designer at the same time. Also, we have learned to pass data between different contexts and talked about the main patterns of application development.